Bismillahirrahmanirrahim. Okay, so let's get started. This is our lecture number 2 on um, the lecture 2 in optics. And today we are going to discuss some basic concepts. Okay, so the first one is that of a ray of light, or simply a ray. Okay, what is a ray of light? Okay, so we say the path along which light travels from a source to an observer. Okay, that path is called a ray of light, and it is represented by an arrow pointing from the source along the propagation direction. Okay, so for example, suppose this is some source of light which is emanating light in all directions. So these are the possible directions. Remember, light is actually emanated three-dimensionally, but over here we can draw just a two-dimensional picture. So light is being emanated in this direction, in this, in all directions. And suppose you are here. So this is the source of light or any other wave, electromagnetic or whatever. And suppose this is you are some observer, and you are looking into the source of light. So for example, if this is sun or this is a bulb, okay, so light is coming to you in this direction. Okay, this direction of light travel, this is called a ray of light, which is geometrically represented by this arrow, such that the tail of this arrow lies over here on the source, and the tip of this arrow is toward the observer. Okay, so remember, this is just an imaginary concept, and this is an imaginary line or an imaginary arrow. Okay, this is called a ray of light. And what will be the practical example of a ray of light? So a thin fine beam of laser, for example, qualifies for the ray. So you know, laser is a device which produces unidirectional monochromatic light. Suppose this is that laser, and this is producing a narrow sharp beam. Suppose this is some blue color laser. Okay, so that beam of laser is represented over here by an arrow, and this ray is called the ray of light, laser light. Now, the second concept over here is that of a wavefront. Okay, so we use the concept of wavefront when we visualize light as a wave or any other electromagnetic wave in terms of the wave concept. Okay, what is a wavefront? A wavefront is a surface at which all the points of a medium are in the same state of motion. Okay, so for example, if light is passing through a material medium, just like the water waves are in case of sound, okay, so as the disturbance passes through some region, all points in that region which are forming a surface, a two-dimensional area, they are in the same state of motion. So this means they are being displaced by the same amount in the same direction. And we have a word for this. We call all those points are in phase, or all those molecules, particles, whatever, those are in phase. Okay, so for example, if you look into this figure over here, suppose this is some calm lake of water, and you drop a pebble, a small stone over here. So as the pebble hits this water table or water surface, what happens? Energy is being imparted to the water surface, and you see then circular waves are produced around this point of impact, and those circular waves travel along the water surface in all directions. Okay, so these arrows, these represents the direction of That disturbance, remember, these are nothing but the rays now. These are the rays of water waves, not light waves, because we are talking about water over here. And you see circular disturbances over here where all the water molecules are either going up or going down. Okay, so we say these the points lying on this disturbance, they form a surface. Okay, that surface is called a wavefront. But remember, this is one of the wavefronts, this one is a second wavefront, and in between these two crests, I should say, in between these two disturbances, there are points within this region where all the water molecules are in the same phase. Okay, they are forming the valley over here. So this is also a wavefront. Okay, so the disturbances with which water molecules move up from their mean position, they are wavefronts, as well as those regions or locations where the water molecules are going down, they also form surfaces, and they also qualify for wavefronts. What will be the shape of wavefronts? So wavefronts can be linear or planar in the one-dimensional case. They can be circular in two-dimensional case, just like you are here in the case of water waves. The disturbance is two-dimensional, and these wavefronts which are circular over here. And in case of three-dimensional emanation or production of waves, they will be three-dimensional spherical. So for example, suppose this is some source of waves, a light bulb or sound source, whatever. Okay, so if you consider this to be a light bulb, so then light will be emanated in all directions from this source. And so these arrows now represent the rays of light. And if you are going to draw wavefronts over here, they will be spherical, just like a football. Okay, so these are called the spherical wavefronts. And remember, a ray of light and a wavefront of light, they are always perpendicular to one another at all points. So you look into this figure and you can see this is a ray of light and this is some portion of the wavefront, and at this location they are perpendicular to one another. They are perpendicular to one another over here as well, and everywhere they are perpendicular. And then the concept of ripples. So ripples are nothing but just symmetric disturbances, either circular or spherical. Okay, so these wavefronts which are disturbances which are symmetric about a common point. Okay, so you can see they are symmetric circles, and these disturbances have been labeled as ripples, then ripples of water.